is, guys, consistent hashing. Okay. Why consistent hashing come into picture is mostly related to. Just a second. Let me check it. Why it's not writing all font color? Okay, font color should be black, guys. Black. Explain. Yaar. Okay. Consistent hashing. Okay, consistent hashing, why it's come into picture? It's come into picture regarding our distributed system. Okay, what in distributed system we do? We have multiple servers needed. You know why? Because we have to maintain or what you can say replicate. One is the part is replicate, and second is the sharding. Those for those reasons we mostly need our distributed system. Okay, and how distributed system use consistent hashing? It's is using it for uh, equally distribute the load upon all the servers. Okay. So
Is it
before
a
coming
load
to the
balancer?
consistent hash, sorry.
If it is distributing the load on all the equal load on all the servers, so can we call it a load balancer?
Yeah, load balancer is one thing. Like it will give you the round robin thing. Okay, the hits it will give to the round robin thing or all the other way. But consistent hashing comes into place where you can say uh, like in Redis when you store data key value pair. Okay, in sharding where you store like MongoDB data. You can take the example of MongoDB where you need to like MongoDB do it itself that the data should be on different servers so that the load should not be come on one server. In that factor, you can say it that it distribute equally.
Okay.
Then first of all, like hash table. If you know, guys, what is hash table? If you anybody of you like want to explain what is hash table?
Yeah, I would like to add.
Yeah.
Yeah, hash table is a kind of data structure which stores key value pairs by following an algorithm called algorithm. That hashing algorithm can be any custom one.
Yeah.
There's a bucket. Yeah, there's a lot of buckets and key values. Value pairs are stored inside it, so they are called entries. A lot of things are there. Yeah, that's all.
Yeah. So, like if I can say like what JB has said, we have a hash function here. Okay. So if we give some data to it, like a input data, then based on that input, we will get here some hash keys. I don't see why it can't like draw the arrows here.
You just drag and drop. It would work. It will connect from the center. From the center.
Yeah, you see, I am doing it correctly, I think.
Pick from the center. You chose from the corner actually from the rectangle. Yeah. Now do that.
Still the same.
Uh, yeah. Just leave it. Leave it now. Why it is happening? The arrows should be there, right? Can you click on an independent arrow in the left panel dashboard and manually insert an arrow? Yeah, this one. Yeah. Now try to see. Uh, it is coming, but it is not visual. I think it is white in
Okay, there
color.
is some color. Lots of color issue is going on. I don't know why today.
Mm,
Maybe
I
the
think
system it's taking the
that may be the
this is the issue.
reason. Yeah, that's the reason actually. The arrow
Yeah,
colors.
there is a system. It is taking some system color. That's
Uh,
why we
Actually,
have
your
faced.
Chrome,
Yeah,
I think your Chrome is in black thing, right? Sun Dracula or something like that.
yeah, yeah. Right.
You can make it light so it can look like that usual one if you want.
Mm, it will take time for me. Let's see if it is correctly right now. Because lots of arrow will be needed in our lecture today.
No, arrows are there. I think if the color is white, that's why it is not visual. You can make it some other color, red, green, blue, something like that. Just, can you click on any random color other than white? Yeah, it is visual. Uh, you can change their color also. Everything is in black. You can change it to green or something like that. Just select the diagram. On the right panel, right top corner, you can see different colors, right? You can select any one of them. No, no, other than the black. No, no, no.
I know that. I know that. I'm not doing that.
Okay.
Like it's taking lots of time doing these things. How to
It, it's just because arrow is a white color, right? Can you change the background? Can you change the background to black? Can you change the background to black? Then arrows would
okay.
be visible, and the black colors should be with different color. Can you change the background color to white?
There is the background color. Let me do it this way. Okay.
Yeah.
But
Now
now
it's
text
showing
will
good.
be the issue.
No, no, everything would work. Now your everything would be in black, so you can change different colors.
Okay. As function. Okay. Those many arrows are present earlier. Okay. It took a little bit time. Let me. We have an input, and based on that, we have a hash key generator. So this is the basic one that we do. So if I take a small example, like we have three servers with us, mm, and let's take that they are connected with either each other, and you want to save all those. What we can do, we can generate a hash functions and take the modulus of the number of uh, servers. Okay, like as we have a three servers here, so we can do one thing like generate the hash key and divide it to each other. Take the modulus of it. If I take an example, you can see here as these are connected servers S1, S2, S3. If I say you have a URL one, okay, then you have URL two, and like that URL three, URL 4, then URL 5. Okay. And now say you the hash key generated, I'm taking a small number for just calculation. It's 122, let's say 123, then here URL, then this is 124, then this is 125, and this is take 128. Okay, if we take the modulus by 3, what it will return us? It will return us 1. Okay, and it return us 0. This will 1. This will return us 2, and this will again return us 2. As you can see here,
What is three here?
sorry,
What was the question? Mode wala?
we are taking a mod, okay, like you can say 121 modulus 3, because we have 3 number of servers.
Okay, 121 is the key.
Yeah, 121 is the hash key that is generated, or I can say here you can say input, or either hash key, and here you can say I have the server name. Okay, so this way you can see our all 4 URL get distributed. Okay, as 4 hits came, they got distributed in all of them, one after other. So till here everything is fine. We are doing good. Now what happens if one of our servers got out by any chance? One of our servers is uh, out of service, or we need to add one server. So what happens whenever you add a server? The modulus will change. Correct. Now our new modulus with what will be our new modulus? Can we increase our table? Let me just add a small row here. Okay, I will show you the new modulus after we increase the server from 3 to 4. Okay, we added one more server here. Now the keys, you can see what the keys will get generated. Or no, key will be same because our hash function will be same. But what the server will generate? Tell me, like 123, what it will give? It will give us 3, right? Now 124, it will give us 0. Then 125, it will give us 1. And 128, it will give us 0. What you can see here, after adding a new server, all our server names get changed. So every cache will get missed, or every data will get missed, because whenever our URL is the same URL came, it will generate the hash key and it will going to search for the server. Now the server earlier it is 0, now it is saying it's on 3. Okay, because of this, all our keys will get again recalculated. So this is a tedious task, and it's not an efficient way to do it. So because of this reason, the consistent hashing come into the picture. This is a normal way to doing it by modulus one. Okay.
Can you explain the problem again? What problem we are now facing? Like server are not sending the URL or the request are coming to different.
Okay, yeah, exactly. As earlier, people just said, na, load balancer is doing the things handling, or I can say here one is orchestra. Orchestration was doing by one our master. Okay, they take this as your slave servers. What happens earlier slave servers? So what the master has the map of all this. That whenever this URL will come, I will go to this server. I will send the request to this server. Okay, whenever the URL 2 will come, I will send it to server 1. Because earlier the number of slaves are 3 in with it. Now as you increase, for horizontal scaling, you need to add one more server. Now the all hash keys will generate it same, right? URL is same, but the hash key will be same. but your modulus will change now.
Yes.
It's changed from 3 to 4.
Oh,
Because of that, all the server calculation got changed.
yeah.
Right? It's now if it's hitting to the earlier server, it will not return it the value. This is the main problem. So what is basically a consistent hashing? What is what brings to the what it brings to the plate actually? So it consists of like two things. One is you can say your hash space. Okay, we create a hash space. If you can say like I will take a small example of hash space. Say it is like a big chunk of. Let me take it like this. Okay, I keep it very big number. Take this as your hash space, and what it does, it will hash ring. It will convert it to a hash ring. Okay, I'm just representing to you in a bigger format so that it will be easier for you to understand. Hash space, and how this hash space will see you can see it later on. It will convert it to something like a ring which are end to end connected. It is get connected.
Half an hour.
Sorry.
It is raining since half an hour.
Yeah, today is rain day, and you can see here this is our hash ring, and in this hash space what it brings a value like what it promised. There are n numbers. If you can say there is n number of slots. Okay, and if you take keys, you have take k number of keys, then it promises that it will reduce your chances of like missing. Yeah, by k by n. Okay, that is its promise, and it is using SHA1 for the hashing, like SHA1 function for hashing. There are many others also. A by n. N is the number of slots in the space. Number of slots, and k is basically your you can say number of keys which are going to generate plus your servers. Okay, so now how this will align to this circle, this ring. You can take an example like that, and let's see. Earlier we have 4 servers, right? You can see like this one. This server will we will place this server here, another server here. This one is the server. This is like S1, S2.
Earlier it was URL1, URL2. Now it is S1.
No, it is already. You see here. These are S1, S2. These are servers, right?
Okay.
So only we are aligning those servers only
Okay.
in a ring basically. Now what happens in this ring? As you can see, these servers are there. So on these slots we put the servers. Along with those servers, whatever the keys. that you get generated here, na? That is input URL 1, URL 2. Based on that, you have a hash keys. You will put this keys here on this ring. You can say like this is key 1 got generated. It will find its own algorithm how to place these things. Yeah, something like that you can see. So these are like key 1, key 1. This is key 2.
What is Q here?
Sorry,
What is Q?
where is Q? It is not Q. It is K. Key.
Okay, K1. K1. Okay.
K1, K2, K3, K4. Okay. I'm just representing these are key values, the hash keys. And what it does, what is the principle of searching now? Earlier you were doing it a modulus, right? Here you mapped it in a circle, in a ring. Now it's easy for searching. How it will search now? It will run clockwise. Whenever there is a new key, hash key generated, you will find that key, and you are going to search that key on the next server
level
clockwise. Like if you can say here, like our K1 is here. Next server you got clockwise is S2. So our
There is a round arrow again.
hmm?
Round arrow is also there.
Where is it?
Curly arrow, yes. Can you try it? Okay, fine.
Something like that. Okay. So this goes again for all those things. K2, K3, K4, all those are generated and placed now like that. So you can also, or easy to understand this thing is like whatever hash space I showed you here, right? This whole hash space is already get calculated. All the places are already get calculated pre-hand, and now whenever the keys get reached to you, it will generate generate the key like URL come generate the key, and it will place that key on that particular slot. Like if you can see here, this is K1 and something like you can think like this. Okay, K2. Now it's easier to search. So yeah, are you clear? Are you clear with this searching option that it is giving here?
Okay, what I understand here, your request counts for key 1. Correct? Though it will search in S2 server.
Right.
But okay, because it is in immediate write. What if it comes to K4?
So it will go to S1.
Okay, so K4 is present in S1.
Right.
Okay, and the same circle has been cut it down, and we have drawn that boxes.
Actually, these are actual boxes. We will represent it as a circular linked list.
Correct. Understood. Fine.
Got it? Now, this is a good solution. If you can see, right, it solves our problem, because whenever a new server get added, it will like only we have to, like you can say here, if I add this new server here only, okay, this is your new server. This is, you can say, S5. Now the only we have to change the keys for Q1, which are like earlier to S5. Rest all keys will point wherever it's needed. Now we have to
So we
change the pointing of key 1 to S2.
so we have to update all the key address to the new server.
Only one key address or whatever the key address between before S5 only.
So whatever key is present between S1 and S5.
Correct. We have to only change those. Rest all
So
are
that
same.
so that could be in millions of numbers. So every new server addition will.
Okay, let's think in this way, people. Your observation is good, but let's think in this way. If you have million of keys here divided by 4, okay, you have to convert all those keys here like millions of keys in the earlier method.
Correct.
Now here you have to divide it only by only 4 months, only 25%. Rest all keys are preserved. Right?
Got it.
So this is the benefit it brings to the table.
The number of keys are reduced by whatever number of server keys.
Yeah, right. Like it's reduced by the gap. Whatever is the gap between the S1 and S5, only those keys get impacted. Rest everything is similar.
Hmm.
Now, as you denoted this issue, it is a genuine issue. Okay, like all those servers we are placed in this way, we can lose many. Like this is 25% is also not a less number. It's a big number. So how we these are one of the problem. This is the problem number one, and the problem number two. One more thing you can see here, as I shown to you that all these four servers are distributed equally, right? On equidistance way. So
Hmm.
that's why it's incorporating a similar number of keys. But what you can see here, as I added S5, now these are almost nearby to each other. Okay.
I would say earlier it was on the similar distance
Hmm.
on 360 degree, or circular is 360 degree,
It's
or
around 90 degree difference is there in everyone. Okay.
in
As I added S5, the distance
uh,
between S1, S5, and S2 reduces.
yes,
So there
but
will be lesser load upon this S5 and S2.
yes,
Or you can see one more way. Let's as I have added, let's remove the servers. I have removed two servers. Now what you can see, the whole load comes upon the S3,
correct.
right? So these are main two problems that arise because of this way. The doing in this way. So how to solve this this problem is a brilliant idea that they bring to the table. What they did, just don't add the servers as S1 and S2 and S4. Okay, what we can do, we can break our servers into different nodes, lots of nodes.
Okay,
Okay, and like if we have 5 servers here, let's divide it by 100. We have around 500 nodes.
okay,
So now what you will get now a different circle. So it is basically increasing the probability.
Okay, one question here.
Yeah.
As you said that number of servers will be 5, number of node will be 500.
Hmm.
How will you decide that you have to multiply it with 100 only?
No, there is no. I just took an example.
Yeah. There is a factor to calculate.
Yeah, so it's not exactly I'm talking. I'm known about that factor. Okay, what they are using, but in this algorithm, they have like in the Dynamo database they are using it. So they have like a claim that while doing this thing, there is a space. This is a space crunch comes to that. So there you can like. What you can say, you can tune this thing according to your requirement. That they have mentioned. Yeah, as you said, na, server take more space actually. So this is one of the con of this. So I'm going to come to that point. Okay. Okay. JB, do you have any question?
No, okay. Till here I'm good.
You are clear about everything.
Yes, yes.
So do I need to draw these notes?
I think yes, because you are going to increase some numbers, right? You are going to
Yeah,
explain
right.
some.
So now server, you can say earlier I am server S0. Okay. Now I am naming the servers in a different way. You can say like as 0.0. This is node 0 for this. You can say I am explaining it like S10. Okay. I am explaining by only taking two example here. S0, then you can say it is 1. Okay. So similarly, so you got the idea, right? These are almost S servers. Now what
What is
happened?
it?
Whenever the all these are distributed now, whenever new server will get added, it will also has lots equal number of nodes, and those nodes are got divide like distributed in between. And the earlier algorithm will be same, like keys will be placed in between, and keys will search the key on a clockwise direction.
I just want to understand what you have named something s underscore zero underscore one, s underscore one underscore zero. Uh, how we came to this name? What how we decided this name? What
Now,
as
okay. So this name is just like I'm telling you a small algorithm here. The algorithm is like you can imagine that we are dividing it like this nomenclature.
okay,
So while writing your own code of this algorithm, you can name it as a different way also.
okay,
So these are virtual nodes. These nodes we can say these are actually virtual nodes. Okay, these are not like a physical thing that is happening here. We are just taken memory location of a server, and we are dividing this memory location like from like 0xx1 to 0xy2. At this location we are taking as 00, and from another chunk of the memory we are taking is as 01. Okay. So this way you have distributed your servers. Now whenever one server go off, yeah, one server goes added, only those nodes, all those nodes are get removed, and almost you will get a distributed way of keys. You have to handle the keys only distributed.
okay.
Okay. So this way they have solved the problem of that distancing that you are earlier mentioning, na? That how the calculation of the space will be solved. So like this way they have solved it. So one of the issue with this is that it will take more space now. It will take more space for the servers, server virtual nodes.
Mm-hmm.
Now, what are the uses of consistent hashing where it's going to use it? It actually going used in like Amazon DynamoDB for partition. Okay. Then data partition in this cluster of Apache Cassandra. Okay. Then
Mm.
also you can say in Akamai CDN and MongoDB it is used. And there is a Discord chat app. They are using this consistent hashing. So yeah, so this is all. We have completed the theory part of consistent hashing. Right.
Thank
It's
you,
a
KK.
small topic, but it's a brilliant one because it saves our lots of practical things that we are doing in our daily life. You know about this DynamoDB, MongoDB, Cassandra, CDN, right? You worked with these things.
Hmm.
So these are like internal things that's going behind. One small example I can say here, like we have in our company, we have implemented for caching only the caching of our a caching layer by using Nginx. Okay, in that Nginx, we are doing this exactly same thing, the consistent hashing. Okay, how we are achieved there, I will explain it by a small example. How we try to achieve actually, I will more clear about that. Let's take we have divided, like we have to cover three servers like this: S1, S2, S3, and or I can like make it bigger for its example. And then we run two ports here. We run our servers on two ports. One port is like 80, and the other one is 81. So what is the purpose of running two ports? This is called dual proxy. Okay, one is like 80 is taking the request from the CDN, that is Akamai for us, and the 81 is our reverse proxy. So whatever the request is coming to the 80, we are redirecting it to the 81. So actually, the 80 is working as a load balancer using consistent hashing in it. And this 81, all these servers are using to cache our copies in it. So this consistent hashing and all, it is given by Nginx only. So we are just using it, and there we have some file. If I want to if you like, I will mention here a small thing like this. This servers has some IPs. So there is a upstream method in Nginx. We will just have to define it like this, and there we will mention our IPs like 192.4.8.1, something like that. Okay. Oh, something like that. Okay. If you can see, this is like 8 and this is like 7. These are three servers, and I'm just not remembering exact syntax. Mostly these are like we write server in front of them, and later here we mention consistent. Okay, so this will show that we have to use the consistent hashing with this.
Consistent hashing comes by default in Nginx.
Sorry, yeah, by
Does
default,
it
yeah. It's come inside Nginx. You just have to start it wherever you need it.
just providing that syntax, it will work.
Yeah, correct. So knowing the concept behind it, you have easier to understand what is the real-time use cases of it. Okay, fine. I'm completed with the session.
Thank you, KK. Thank you very much.
Thanks, Kankan. Good job.